idle. All right. So let's. Very nice.
I couldn't find it.
If you don't start every lecture that way, I'm going to sue for like the lowering of the quality of the class.
Which the false idol or the gong?
The gong.
Well, we only did the gong today, and because Alex is missing because of the diarrhea and vomiting, vomited,
And fever.
vomited. All right. So last time we have it set up where our socket connection is we're sending the file one byte at a time across the stream, right? And right now we have it where we're advertising ahead of time how many available bytes there are. We're doing that between the client and the, let's see, it's at the, oh, we didn't actually use our file reader here. I'm going to close that for right now. All right, so this is the client connecting to the server, and this is when the client tells the server how many bytes he's about to send. All right, and we're doing that based on the available bytes left from the client side, which is, we did create a new object for client, right?
Client communication protocol.
Is that this guy? Thank you. So right here, he's writing out the number of bytes, fizz.available, and then as long as there's still bytes available locally, he's reading it in and reading in 1 byte, writing out 1 byte, over and over and over again. So we're sending things 1 byte at a time. Now for right now, we're going to say that's okay. We have some options to send things in multiple bytes at a time and things like that, but that actually might muddy the water for what we're actually trying to accomplish. Because remember, we're trying to create kind of a BitTorrent clone. And the way BitTorrent works is each individual client is sharing bits, sharing bytes, as well as receiving bytes. Well, that's interesting. Why would they call it BitTorrent if it's actually sharing bytes? Actually, I think it's sharing more than just a byte. I think it's sharing, the smallest pocket is like 64 bytes or something like that. That's the smallest you can send.
I'm trying to mislead you.
Huh?
I'm trying to mislead you.
I'm trying to mislead me?
No, they are.
Oh. So in any case, our goal here is we want to have a situation where we have one file, and that's our file. All right, so we have one file, and this file might exist in pieces at various places. So we're going to say that's a partial file, that's a partial file. Here's the original full file. No harm, no foul. And then we have the clients. So this is the original client who owns the full file. Here's a client who currently has a partial file, and here's another client that currently has a partial file. And all of these clients were connected together through a central server, and we're going to be getting to that. So these guys were connected through the central server that actually manage the initial connections, handed off sockets. Okay, so in the end, these guys are actually directly connected to each other, but they were directly connected to each other after this dude connected those dots. Okay, now what we have set up right now, this is what we're trying to set up. What we have set up right now is the ability for our client to connect to the server, and the server then gets a duplicate of the file. All right, that's what we currently have set up. So these guys aren't even in play yet. Okay. Now what we want to do is we want to make it so that this guy and this guy can download this file in, let's just say, in an efficient way. We're not going to say the most efficient way yet, but in an efficient way. with the idea that, let's say this guy connects first, and he starts getting some of this file. So now he has a little bit of it. Now this guy connects. Who does he get his next piece of the file from? This guy, or both? And how do we manage that protocol? Last time we started talking about protocol, we even created a object for it. But we need to decide who sends bytes to who. Okay? We can make this connection. We've done that. Right? We've done the connection where two guys connect to the central part. We hand off and the sockets are talking to each other. But how do we go from this scenario where I don't think we want our server storing the file locally, right? That doesn't help us. Now we're right back to a client-server model. All we've done is this guy's basically uploaded his file here so these guys can both download it from that one source. It doesn't really it solves the problem, but not in any sort of interesting way. We want to have it set up where this guy can connect here, find out that this guy has a file, connect to him, and then all these guys kind of create a web, and they're getting and sharing bytes at the same time. How do we organize that? So forget about our duplicate file here. This guy's purpose is just going to be to interconnect these clients. Okay, so these clients are now glued together in some interesting way through live socket connections. Okay? How does this guy get his files to this guy? And who does this guy get his bytes from? Does he get it from here, a little bit of both? And then explain. And this is really a choice we get to make. We get to choose what our protocol allows. Are we literally doing this at the granular level on a byte by byte basis? Or are we grabbing things in 100 byte chunks? Where 100 bytes that's the minimum size I can grab from anybody, or maybe even the maximum size. So 100 bytes, 100 bytes, 100 bytes, 100 bytes, and you insert them into the right place in the file, and you're done. How would you suggest we do this? So this guy has a part of the file. This guy has a part of the file. So we'll say that these guys all have a piece of the file. Now what I'll do is I'll give myself a fourth guy here. And this guy currently, he's got nothing. He wants to have bytes from these files. Okay? So these guys are all on the same torrent, if you will. Who does this guy ask for bytes? And why? How do you think it should work?
I think. Can you get you can get bytes from multiple places at relatively the same time, correct?
Yeah, fair enough.
So he could ask one of the non-original people for the beginning of the file, and ask the original person for the end-ish of the file, and stitch them together somehow. Because that way, every person who joins would always have the beginning of the file. So no matter who you ask, you're always guaranteed to be getting the beginning of the file at least.
Okay, so you're essentially saying maybe we should make some guesses as to who is likely going to have parts of the file.
Yeah.
So when this guy comes in, he's probably fairly safe asking not the original owner for the first byte, because they're likely going to have that first byte because they probably went through the same thing when they first came in. But then for any additional parts of the file, you're safest to ask from the original guy. Well, now that's back to a client-server model. We want this guy to be able to stream bytes from all sorts of different locations. Is there one guy in this entire model who knows the state of all of our individual clients? The server. This guy, he can know about everything. And we really created kind of a predecessor for this. Remember when we had our linked list of clients on the server? It's the client, it's the server. Yeah, here, we had a linked list of clients. So the server knew about every guy that had ever connected. All right? And even though those guys might be talking directly to each other for certain things, the server can kind of organize stuff. Would it be horrible overhead for the server here to keep track of maybe a list of clients and what bytes they have? Almost like keeping score. Like this guy has all of the bytes. This guy has bytes 1, 17, and 34. Whatever. Okay, this guy has none of the bytes, so on and so forth. So we kind of have a single database, if you will, up here of all the different clients that are currently the people who are receiving the file and the people who are retrieving the file and the people who are doing a little bit of both. All the different information about who has what. So when this guy comes in, instead of him making a guess, who do I talk to? He goes to the server and says, I want to get this file. I want to get this. I want to get this file. And what the server might do is it might say, okay, well we have 3 connected seeds. 3 connected seeds. I can give you bytes 1, 2, and 3. Let's just keep it easy. From 3 separate seeds, and send them all to you. But it's not going to come through this guy. It's going to say, okay, you're going to get byte 1 from this guy. You're going to get byte 2 from this guy. You're going to get byte 3 from this guy. That makes sense? So there's a protocol in there because you're requesting a certain byte number or a certain chunk. We're just going to, for right now, let's just work with it in individual bytes. Then we can decide how we can make this more efficient by grabbing larger chunks. Working with individual bytes, what we're going to have is we're going to have a very chatty protocol where we spend more time talking than actually getting data. Because we'll have to pass back a couple of things before we actually just grab 1 byte. Whole lot of work for 1 byte. But that's what we're going to do. That way we can easily talk about bytes. Okay? So this guy will connect to the server, say I need bytes. So the server will know what he currently has and what he doesn't have. And then the server will say, okay, here's a socket, ask him for byte 5. Here's a socket, ask him for byte 7. Here's a socket, ask him for byte 214. Okay? Kind of make sense? And then down here, this guy's collecting. He's collecting this file. But understand that the way this file is actually getting collected is a big array. Something that looks like this that we're filling up 1 byte at a time. All right, so 2 challenges here. We're doing this whole 1 byte thing, and this is going to actually exaggerate our challenge, but that's good for us. Understand that each of these guys has this array. All right, now if we're just sharing a JPEG, smallish file, is there any problem with the original guy loading his entire file into a byte array? No big deal. That'll fit in memory, right? Okay. So this guy can literally load all of the bytes into a byte array. And then when this guy says, I need byte 14, he just goes to bucket 14 and grabs the byte. Correct? And passes a byte out. This guy, then, he's just going to be receiving bytes into his array. And when he asks for byte 14, he'll put it into bucket 14 of his array. Once his array is filled, that is, he's got all the bytes, and then he can just spin through it and write it all out to disk. Right? Okay. That would work for a file like we're working with here. Small file. Well, let's say we have a 5 gigabyte movie. Blu-ray rip or something. Okay, so a 5 gigabyte movie. Can we have this whole array? The short answer is yes. Should we have an array to hold all that data? Probably not. So if you want to make it official, it's a 30 gigabyte file. You're not Haxton. So you don't have, what does he have, 32 gigs of RAM? So you don't have 32 gigs of RAM. So it's a 50 gigabyte file. So you are Haxton. And so you can't create a large enough array to hold all the bytes associated with your file.
Array, you can't do the
All right, so how do we solve this problem then? There's some challenges. So now this is a 50 gigabyte array. We'll just assume for a second that we could have created this. All right, so this is a 50 gigabyte array. Well, we can fill it up, then we can write it back to disk. Still need 50 gigabytes of disk space to hold it, everything like that. But now if we can't create 50 gigabytes, and this guy tells this guy you can request byte 17 from this guy, where does this guy get byte 17 from? He doesn't have this array. This array is not just sitting there ready to feed bytes. Instead, he has the whole file sitting on his hard drive. Well, can we read in byte 17 directly from a file?
Yes.
Okay, how?
Listen, see, you have like a FC can just give them.
Okay, so we can actually move to a certain place in a file. And we're going to talk about the downside of this. Where are we putting the wear and tear on our computer? So now we're having hard drive issues. So seek is going to be probably in file reader or file input stream. Do you happen to know? Let's see if it's in file reader. Yeah, so you can read starting at an offset. So read up to, so we would read, in our example, 1 byte, starting at, if we were reading in byte 17, let's say, we would start at, let's just assume we were doing 0 index, so byte 17 would actually be a bucket 16. So we'll go to bucket 16, and we'll read this into, this acts as a buffer, a byte array. So we'll actually just store it in an array of one thing, since we're just doing 1 byte at a time for right now. Similarly, we could do this. We could skip a bunch of indexes and then read directly from it. So this will allow us to jump through as well. So we can just do a skip and then just do a read. No harm, no foul. To skip through an input stream, we are literally having to walk through our file system. That's putting stress on your hard drive. So let's think about this from a BitTorrent perspective. If, especially in this exaggerated case where we're only reading 1 byte at a time, if you have, let's just say it's one of the popular files, probably the person who got the screener for the latest movie that just started tomorrow.
Why you gotta judge me?
That one. And let's say there's 500 people currently participating in this particular seed. So let's say you have 300 requests coming into your machine asking for an individual byte. So you're going to skip through the file to get to this byte, feed it to this guy. Skip through the file to get to this byte, feed it to this guy. Skip through the file to get to this byte, feed it to this guy. You're doing a lot of moving around on your hard drive. That's going to put a lot of wear and tear on your hard drive. Is that what we should be doing?
It's okay.
Solid state drives still have a finite number of read writes, just higher.
Won't that change once the 3D NAND gates are implemented?
There was always going to be something. There's always going to be something. So what do you think? Is this the solution? Maybe. Is this at least a reason to maybe not do this 1 byte at a time? Let's take a little bit bigger chunks. Make sense? All right, so for us, we can certainly do it this way for now. Okay, but before we start doing the skipping, we want to go to our regular model of let's just read the entire thing into an array. Makes sense. We're dealing with JPEGs. Okay, initially our client server can only handle JPEGs. Okay, so we go back into our code here. And what we'll do is this is our client communication protocol. Right now we are reading and writing directly out to the client. So we're just going to change this up a little bit. This is where we're getting the file, right? We'll just put it down here. So we're going to create an array of bytes. In this case, it's an integer array, since that's how it reads in unsigned bytes. So we're going to have an integer array called the file bytes. And this guy will be a new integer array of phys.available size. Okay. Right now we are letting our server know how many bytes we have. Okay, but at this point, the way we have it written is our server is receiving this file and writing it locally, instead of building up a database of who has what bytes to what file and then accepting requests. So that's what we're going to be adding. Okay, so we're going to create an array big enough to hold all the bytes. Then we will I'll just comment this out for right now. We're going to need a loop that's going to go through, and we'll say int pause is equal to 0. The file bytes at position pause is equal to phys.read. Okay, we could certainly say pause plus plus if we wanted to there. I claim that's bad programming practice. So I'll just put it on its own line. So we'll read in byte 0, read in byte 1, read in byte 2, read in byte 3, all into this array. Okay? Now we still need to write it out to our server eventually. Well, actually, you wouldn't write it out to the server. You're going to be writing it out to somebody. So we'll get rid of that for right now. I must already have a pause in here. I do. Did I already use it? I should just be able to zero it out then. All right, so now I've locally stored the file I want to share. All right, once I've done that, let's just get rid of this code here. So we'll say that we locally buffered our file into an array. Okay, now the client does what? If I'm the client and I've said I want to share my file, and now I've buffered it into an array, what mode am I in now? I'm the original. I will not be downloading, at least not on this thread. I won't be downloading any files. The client just became one of potentially several servers, right? So now I'm a server. Well, how do I receive requests? Prepare to receive and respond with byte requests. All right, so for right now, we'll just say while true. Not great programming practice, but we'll do that. So in perpetuity, this guy's going to sit here and receive requests. Okay? Now, the server is going to handle making requests to him. And we'll test this for right now by the server being the only guy. Okay? So we're going to stop right here on the client side. And now up at the server, which is our response thread. Actually, I want to get out to driver for the server first. Here's our connected client. We add it to our clients. Fine. There's a response thread. Start it up. Here's response thread. This guy knows about this particular client. Now our connected client is currently, okay. So here's each of our connected clients when we establish a communication channel with our server from the client side. We know about the socket for that connected client. We have a print writer to write out to them, and we have a way to read in from them. These are all textual reads and writes. Okay, we'll add some more features to that. Now a potential connected client is going to have long-term maybe an array of files that he's currently sharing, because with BitTorrent you can have 5 or 6 things you're seeding at the same time, right? No problem. For ours, initially we just have one file that we can either be sharing or receiving. All right, so we're going to go ahead and we're going to create up here at the top level private int array. Actually, this isn't going to be an int array. This is going to be, well, seems like a really stupid way of, it'll make the most sense. When else do we have an opportunity to make a Boolean array? So I'm going to make a Boolean array. We'll call this guy my bytes. All right. Now, when a connected client has let us know that it has some bytes available, specifically one that's sharing, this guy is going to have to create that file locally. So this is the original guy. So I'm going to go ahead. We're going to write a public void init bytes int size, and this guy will say this dot my bytes is equal to new Boolean array, and we're going to make this of size. Okay, so most of you probably have not seen this before. Instead of writing a quick little for loop that spins through and fills your array up with a bunch of falses, I'm just using the arrays class, which has a method called fill that allows me to fill up an array with these values. This will just fill it with falses. Class method or instance method, Abe? Actually, Nick. Answer it.
Instance.
Tell me why you're wrong.
Oh, there's no static in front of it. It's class method.
Tell me why you're still wrong.
I don't know. I'm out of it today. I'm an idiot.
Huh? I suspected Abe would get it right, but actually Abe did really crappy his last assignment, so maybe not. I think it was you.
The one where you forked his code?
No, not that. The previous assignment where you had to send the stuff over the socket.
Yeah, he forked your code on that one.
Yeah, it didn't. I think you basically submitted my old code, didn't you?
It worked.
Really? Maybe I'm thinking about Tim. Class method or instance method, Tim? Class method. How do you know? Because I told him that instance method was wrong. Because why? Because when did I import arrays? No, I didn't import anything. Yeah, all you have to look at is this one line here. It's all the information you need. I didn't import any magical evil.
I thought we were talking
No
about,
static, you're still wrong.
I thought we were talking about the init
This guy, right here.
Oh.
Class method or instance method.
Oh.
I had it highlighted. He's been
I didn't
confused
look
for
up.
like last week.
Yeah.
It's okay. Same boat.
All right, this guy's a class method. Why is it a class method?
Because you're calling it using the name of the class.
Because I'm calling it using the name of a class rather than an instance of the class. We know this guy's likely a class because it starts with a capital letter. Okay, class methods are called using the name of a class in which they were defined. Class methods are defined, Nick, with the static keyword.
Yeah.
All right? So, little convenience method that lives in the arrays class for doing things to arrays. All right, so when we init bytes, we will pass it how many bytes we're initializing. We'll set our mybytes array equal to that guy, and then we will fill it up with a bunch of falses, which means I don't have byte 0, I don't have byte 1, I don't have byte 2, I don't have byte 3, so on and so forth. Perfectly good use for a Boolean array. All right. Now we're going to go ahead and add a method for. Now we're going to write a method for adding a byte to our array. So public void add byte int byte, int the byte, int index. And this guy will set my bytes at bucket index equal to the byte. Okay? So he's going to take a byte as a parameter, and we will add it. Oh, I'm sorry. It's actually kind of ridiculous how I wrote that. I need to, it's not taking in a byte, it's taking in just this. Called it added byte. Added byte. So it's going to take in an index, we'll go to index, and we'll just set it equal to true. Because we'll be reading it into our array someplace else, but then we're going to allow our connected client to know that we actually have that byte now. So somebody could request it from us. Okay? Actually, are we reading it in someplace else? Connected client. We could actually just control 2 arrays in here. We'll figure it out here in a few minutes. Right now, we just want to say whether we have it or not. All right, so init byte sets the size, fills it up with falses. Add byte just sets what used to be false equal to true. That's all connected client knows how to do right now. Response thread, it has this particular connected client, that is the connected client associated with this communication channel to the server. And down here, when it gets in the size, we need to go ahead and set this dot the client dot init bytes equal to the size. So that'll initialize that array to the appropriate size and fill it up with a bunch of falses. All right. Then we still print out we're about to receive something. We go ahead and we create our file, file output stream, blah, blah, blah. Here's where we're actually reading in the bytes. So right now we're reading it in and writing it directly out to disk. But then what we want to do is we want to say this dot the client dot add byte I to mark our array as being filled up with bytes. Okay, so every single time we read in a byte and write it out to our disk, which will change, this guy won't actually be reading in bytes in a little bit. All he's doing is he's keeping track of what bytes each guy has. Okay, so we're kind of in limbo right now. This guy will add the byte, and now when we're done, we should be able on the server to say something like, well, here, I'll do it at the end. It says done, so we'll do for Boolean B. Actually, let's do it in communication protocol. Oh, sorry. Connected client. Just going to write a quick method. Display bytes. And this guy's just going to go through. All right, so he knows how to display bytes. And what we'll do is we'll call display bytes twice. We'll call it before we fill it, we'll call it after we fill it. Fairly trivial, but we'll have a bunch of falses, then we'll have a bunch of trues, proving that we're marking what this guy has and what he doesn't have. All right, so down here in so we'll do this dot the client dot display bytes. So this will be all of our falses. Then at the bottom of that, we'll say we're about to receive a file of a certain size. Then we'll actually receive it. And then we'll write out all of our trues. So a bunch of falses followed by a bunch of trues. The server up and running. Well, actually, I need to just delete the file that used to be there. Go ahead and run our server. Server's waiting. We'll connect with our client. Which file? 1. Okay, so it said it locally buffered file. Actually, do we ever send it? I don't think I do. Yeah, it's just waiting to receive. Oh, I said I was going to come back to sending. So yeah, those are all the falses, and it's saying it's about to receive something. So let's go back to our client communication protocol. So we have this guy set up to prepare to receive something, but for right now we're faking it by pretending like the server is who actually requested it. All right, so we're just going to go through and spit out everything that's inside of our byte array. So we're going to say for int a byte in the file bytes. We call it file output stream. Well, it's not a file output stream, it's just an output stream. What's the name of my server? This dot's a server. Okay, so this dot the server dot get output stream or get traffic class dot write a byte. Okay, so he will now write it there. The server will then receive it. That's in our response thread. So this is when he's receiving it. Then we'll close it, and we should get a bunch of trues. Kill this. Kill this. Need to recompile our client. Server's waiting. Client's connected. We're sharing that. Locally buffered file. So we should have a bunch of falses followed by a bunch of trues. Somewhere in there, there's the
Too many.
okay.
Oh,
It was about to receive 45,626 bytes. Then we received them all, and there's all of our trues. Okay, so now the server is aware that this guy has all those bytes. Okay, now the server is not in charge of. The server's not in charge of whether or not bytes will always flow through the server, but the server isn't the one storing the bytes. Okay, so an important thing in this, the server's not going to store bytes. Right now we have the server also acting kind of like a client. Now let me ask you this, since we ultimately set our array of my bytes all to true, because we read in everything, when a client first connects and says, I'm going to share my file, isn't the client then saying, I have all the bytes by default? Therefore, couldn't we come into connected client, and when we initialize something for bytes, couldn't we just go ahead and initialize it to true, knowing that guy has all the bytes? By default, the dude who's sharing the file has the file, correct? Which means he has all the bytes associated with the file. So we don't need to actually read those bytes in to prove it. So now the server's going back to acting like a server. He's in charge of connecting people who are interested in downloading a file with people who have the pieces of that file. All right, so we'll go back into our response thread. Now he's no longer reading stuff in. We don't have to actually call add bytes for this guy. This is for a guy about to share something. But remember, we have two different kinds of animals connecting to our server. In this case, we have a response thread being generic. You know, when we say run, this guy is getting the file name. We're just assuming that the person who's connecting is always somebody wanting to share a file. We're going to need to change that where clients go into two different modes. I'm in a sharing mode or I'm in a receiving mode. Okay, so when a client connects and they're going to receive, they need to be shown a list, in our case, since we're not going to create a format for torrent files. But they need to be shown a list of currently available files. And in our case, there's only one. Only going to be one file available. Does that make sense? And then once he says, oh, I want to receive that, that's the file I want, just press 1 because that's the only file you have and it just happens to be the one I want. Then the server will do the job of making sure this guy gets all the bytes that he needs. The server is going to be going through and saying, okay, here's the bytes that you currently have. Who has bytes that you're missing? And then connecting with those and telling you to request those bytes. That makes sense? Okay. We'll have to decide next time whether it's the server's job to go through and look through your array of bytes and determine that, or if it's the client's job to notice his array of bytes, what he has and what he doesn't have, and then come in with requests for, I need bytes. So the client maybe says, I need byte 17. The server then says, okay, who has byte 17? And then connects the dots. That makes sense? That's where the protocol comes in. The client is requesting a byte. The server responds with the dude who has the byte. Make sense? All right, so we'll come back on Wednesday and we'll write that part. And then you will probably have a homework assignment on Wednesday due Friday to finish up that communication for having multiple clients connected.
We don't have
We don't
Friday.
class Friday.
It's still due on Friday, isn't it?
You can make it do Friday, but
I'll see how big I want to make the assignment. Oh, yeah, it's Good Friday coming up. We don't have class Monday either. So what I should do is just give you a monster assignment that's due on Wednesday. You have to stay in all day on Easter working on it.